Three-phase motors can run in star or they can run in delta. It's not unusual though for larger motors that need to run in delta to start in star first. And the reason for that is that a large motor will draw a tremendous amount of current on startup. So it's often easier just to get the motor moving in star, which is going to draw less current, provide less energy of course, but just to get it moving, connect it in star, get it running for a short while until it's running reasonably freely, and then the motor contactor will swap over and it will connect the windings into delta, and then it will run forever and a day until there's a problem. Motor starter, a star delta starter, is made up of obviously several components, but the main components being the main contactor, which would have overloads built into it so that if the motor overload, it would open the control circuit and close the whole system down. The delta contactor, which when it closes connects the windings into delta, and the star contactor, which when it closes will connect the motor windings into star. The important thing is, of course, that both of these contactors must never be allowed to close together. If the delta contactor and the star contactor were both to close, if you follow the cables around, you'll see that you'll end up with a massive short circuit and there'll be a massive bang. We don't want that to happen. So within a star delta starter, there'll be an interlock between the delta contact and the star contact. This is the insides of a star delta starter. Not quite set up the way I did the drawing on the board, but nevertheless it works exactly the same. We've got three contactors. This one in this case would be the main contactor, this would be the delta, and that would be the star contactor. These are the overloads, and this is the timer I was talking about, which you would adjust to suit the load on the motor really. Just really want to show you the interlock. If I push this one in, which is the delta, I can't push the star contact in at all. If I push the star contact in, it's impossible for me to push in the delta because there's an interlock between the two, a really very important part of this piece of equipment, you know, because if both of these go in together, you can see exactly what would happen. The current would flow through, and of course, all of the lines are shorted out in the star contactor. I'm just going to change the drawing now to show how the connections would be in star when it first starts up. You can see in this drawing now, I've changed it slightly so that the main contactor, the contacts are closed. Current will now flow down through the motor windings, back up to the star contactor, which is also closed. And when it closes, it joins the other ends of the windings together, look. So we now end up with a star formation. We've got our L1, L2, L3, and these three are joined together here. The motor will now run for a period of time, only a short period of time, until it starts to run freely. And then the person who's installed the motor would need to alter the timer so that it changes over to delta at a sensible time. It could run in star for a reasonable time or forever, it won't make a difference to it, but it won't be doing the job that the motor's intended to do because it won't produce enough energy or even go fast enough. So the idea is let the motor run for a short while, wait until it runs freely, you can normally hear that, and then adjust the timer so that the motor starter now changes over to delta. I've now changed the drawing so that the starter is now connected into delta. And if we look, we can see that our main contactor is closed, delta contactor is closed, the star contactor is now open. And as I said, this interlock prevents them both closing together. If I follow L1 through, we've got L1, it goes through to W1, okay? And along here through to V2. If we look at the drawing over here, this is our delta formation. L1 connects W1 and V2. Just to repeat, if we look at the main contactor, L1 comes down through the overloads to W1 terminal on the motor. Also connected into the main terminal is the L1 cable into the delta contactor. If the delta contactor is closed, it now flows through this terminal. If we follow it round, it connects V2. So if we now look at our drawing of a delta formation, we can see that L1 is joining W1 and V2. Or rather than joining, L1 is supplying W1 and V2. So that's the first step really, isn't it? If we follow L2 through, L2 connects V1, which is here. The same conductor, L2, now joins onto this red conductor and it joins U2. And if we look here, we've got V1 and U2 connected to L2. Same again with L3. We follow L3 through, connects U1, which is here. Also from the contactor, L3 goes into the delta contactor, through the contactor because it's closed. Follow the blue round and it connects W2 here. So now we've got a motor that's running in star. And as you can see, this contactor is now open because if it wasn't, if we were to close it, as I've already said, we would get a short circuit through there. The motor will now run for however long it needs to run for. If ever it stops for any reason, if it's doing a job and it needs to stop, when you start the motor again, it will revert back to exactly what we did before. It will start in star, run for a short time, the timer will cut in, it will change to delta, and then it will run forever again. You'll notice that in this drawing I've used odd colours. It's because the colours, the grey, doesn't show up very well on the board. So I've just used the brightest colours I could find. I know they're not the right colours for L1, L2 and L3, but actually it's just the way it works I'm trying to present to you, not the way the colours should be.